Hello everyone, and welcome to the MLOps workshop. Today we're going to be getting hands-on with the Onnx format. So this is the same example that I used for the previous videos where we walked through packaging a model using the MLflow framework. So we'll just quickly walk through this here. I'm installing transformers, the Onnx framework, and the Onnx runtime. Here I'm just mounting to my Google Drive so that I can save data artifacts. And so this should all look familiar. We're just importing the BERT tokenizer, the pre-trained BERT language model, and we're just generating some sample inputs by tokenizing the here is some text to encode string. Okay. And if we conduct inference on this model, we can see here's the output from the language model. This is the same as what we got in the MLflow models. And here we can see the shape of the output, 1 by 9 by 768. Okay, so here we are at the Onnx section. We're importing a couple libraries, the Onnx and the Onnx runtime. We are defining the Onnx path. This is where we're going to be saving our models. And we're also going to create a sample input IDs variable, or tensor, I should say. This is just tokenizing the here is some text to encode string. So what are we going to be using this sample inputs ID for? When exporting a model to the Onnx format, PyTorch uses a trace-based approach. This is what we'll use this sample inputs IDs for. It's essentially just a dummy variable. So if you're curious about what trace-based means, we can go ahead and look at the pytorch.org/docs/stable/onnx. I highly recommend you guys check out this page. It's full of a lot of very useful information, and including end-to-end examples of going from PyTorch to Onnx. And how I previously discussed in the overview video, there's actually a built-in functionality to PyTorch for exporting to the Onnx format. We can see here torch.onnx.export, but we'll see more of this in the hands-on video. So here we can see tracing versus scripting. Tracing, we can see trace-based means that it operates by executing your model once and exporting the operators which were actually run during this run. So essentially what trace-based does is we pass through a dummy variable and all of the operations done on that variable are recorded, and that's what's serialized out. So that's why we need to pass in this sample input when we export our PyTorch model to the Onnx format. So the first parameter here, we're passing in our model, as we just discussed, the dummy variable, and we're passing in the path to where we want to save our Onnx model out to, and then we're also providing input names and output names. This serves as the naming convention used for the nodes on the graph, and we'll see down here in a minute. So if we run torch.onnx.export, and then we run an ls, we can see that here we have our BERT_static.onnx. So we can load this back in by just calling onnx.load and passing in the path to our data artifact. And now we can inspect what this returned. So we can see if we call .graph.input and grab the first input, we have this name input. This is what we provided up here. It's just a way to name the nodes on the graph. And we can see there's some other details here, tensor type, shapes, the dimensions, and we can also visualize or inspect the output of the graph. So we can see here, again, we have tensors, we have the name, the output that we provided, and dimensions. So we can see this dimension value 768. If we scroll up, we can see that we did get the same dimension value 768 returned from the model when we passed through our sample string before. And now we're going to see the Onnx runtime. We start by initializing an inference session like we're doing here. And if you can remember this ORT, this is just how I imported the Onnx runtime as short form. So ORT.inference session, and we provide the path to our outputted data object, or the outputted data artifact, the Onnx model. So if we run that, if you remember from the overview video, a few things happen here, but mainly this model gets loaded into memory. So now we have some input IDs. We're going to use this. It's the same text as above. Here is some text to encode. We're going to create the input dictionary that we're going to feed into the Onnx runtime. So we can see that we're just creating a standard Python dictionary. The key we are setting to is the static Onnx static model.graph.input.name. So we can see up here, right? This was the name that we provided when we serialized the model out. So we're providing a value for this input key here. So, and what we're going to be passing in is this sample input tensor. The Onnx runtime doesn't accept a tensor as the format for inference. It actually accepts NumPy arrays. So we're going to convert our input IDs from a tensor to NumPy like this, and then we're going to record our outputs by calling ort_session.run. I believe this first parameter we pass in output values, which we don't need to do right now. Again, you can look all of this up in the Onnx documentation for further clarification. We can see the first parameter is output names, name of the outputs. So here we're going to pass in our inference input as the second parameter to the .run command, and we'll print out the outputs. So here we can see we get the exact same output as we did above, which is great, and which is what is expected because we passed in the exact same input. But let's try something here. What if I wanted to conduct inference on a different string? So here is some more text. Let's try running this. So we can see that this breaks. Onnx runtime error, invalid argument, got invalid dimensions for input. Input for the following indices, index 1 got 10, and it expected 9. So we can see expected 9 got 10. The reason for this error is because we added in an additional word to this string. So this is obviously a problem and not the desired behavior of our model. So let's see how we can fix this. So let's head back to the documentation page that we were on before, the pytorch.org docs stable Onnx. And let's do a control search for LSTM. And here we can see the number one question in the frequently asked questions section is, I have exported my LSTM model, but its input size seems to be fixed. So we can see the tracer records the example input's shape in the graph. In case the model should accept inputs of dynamic shape, you can utilize the parameter dynamic axes in the export call. So let's go back over and see how we can do this. So here we can see I have another sample dummy tensor, and we're going to call torch.onnx.export again. This time, again, we're passing in our model, the dummy variables, the path. This time I'm going to be naming it BERT_dynamic. The input names and output names again. But this time, we're going to provide a dynamic axes parameter. And we're going to say the input node, and we're going to pass in this sequence value. So again, this came directly from the Torch documentation on how to do this. We can see you can provide dynamic axes on any of the dimensions. So for instance, if you wanted to pass, I believe any of the dimensions anyways, if you wanted to pass in, say, a batch instead of a single item, then you would set the dynamic axes to the 0th index, and I believe you would also have to set the output as a dynamic axis, yes, for sequence as well. So let's try running this now. If we run a quick ls, so we can see we have our BERT static and BERT dynamic. So now let's go ahead and load in our new dynamic version. And again, we'll inspect the graph. Graph.input, we can see the name is still input because we provided this name up here. We can see tensors, the different dimensions, and this time we see a dim param sequence, whereas above we had dim param 9, right? And this is where we got this error, expected 9, got 10. So now it says sequence. So again, we can inspect the output as well. This should just be the same. We'll initialize another runtime session, but this time providing the path to the dynamic version. We will generate another input tensor. Here is some text to encode. Again, create the input dictionary, convert it to NumPy, and let's run it. So here we can see we get the exact same output, which is expected because we're passing in the same value. So what if we now do, here is some more text to encode. So we can see this time we don't get an error and it works as expected. This is some more and more text to encode. And it works because we've allowed for dynamic values at that axis. So yeah, this is this was a hands-on walkthrough of packaging a PyTorch model to the Onnx format. It is a very, very new technology. It's not as user-friendly as more mature technologies. So, typically that takes a little bit more effort getting up and running and understanding how the frameworks or packages work. But I would start with, if you're primarily using PyTorch, again, like I said before, I would start with this documentation page. It's great, and it'll save you a lot of time and headaches Googling these weird problems that come up when you're first experimenting with this framework. I know I ended up running into this the first time I was experimenting with the Onnx format. So yeah, it seems like a really cool piece of technology, and yeah, I hope you enjoyed the walkthrough.